Before we move on to the third type of domain issue, I would like to do one more example. In the previous two videos, we talked about how to find the domain of a rational function, a function with a fraction, and specifically a denominator. And in the other one, we talked about finding the domain of a radical function, specifically a function with a square root. But there are functions that contain both, such as this one. So how do you find the domain of a function like q of x equals the square root of x minus 5 all over x minus 8? That has both radicals and denominators. And the answer is, you deal with both of them and make sure your domain abides by what each one requires. For example, because of the denominator, we need to avoid x minus 8 equals to 0. That means that we need to avoid x equals 8. Okay, if there were not a radical, I could get the domain right now. But because of the radical, we need to require that x minus 5 is greater than or equal to 0. Well, that's pretty easy to solve. Just to add 5 to both sides. So we need x to be greater than or equal to 5. So how do you find a domain that satisfies both of these requirements? Well, let's draw a number line. Let's start with the second part of the domain, x is greater than or equal to 5. Here's 5, bracket, shoot it off to infinity. Now, why can't I just say that's my domain? Because that goes right through the number I need to avoid. Somewhere to the right of 5 is an 8, and we need to avoid it. So let's remove it. I've just partitioned my domain into two pieces, the piece between 5 and 8 and the piece to the right of 8. So I need an interval for each one. The interval between 5 and 8 is bracket 5, comma 8, but the 8 has a parentheses because I removed the 8 from the domain. Union, on the right side of 8, parentheses 8, comma infinity, parentheses. Again, parentheses on the 8 because I removed it from the domain, it's not there. So it's really not too difficult to do a combined domain situation. You just need to make sure that it satisfies both criteria. We avoid 8, but we're also greater than or equal to 5.